think only about 5-6 people, but I guess we should start. It's already 5 o'clock, right? Should we start? Hi, Ankur, can you hear me?
Hello, sir. Yeah. Yes. So, like right now we have 7-8 participants. I think we can start.
Should start. I was trying to join from my other writing device. I'm facing some difficulty there. I think it's this thing is. Let me see. I was thinking if I can write. That's sign out. Okay, let me try this. Okay, so maybe it's work. So I'll take this time to try and sign in from my other device, then I can write. It will also give us time for more people to join.
Okay, sure. Sir, we'll wait for 2-3 minutes. Then more people will join.
Yeah. Ankur, can you? So you am I logged in through one more ID? Can you see me? I just logged in on the other one. If you can see me, I think you have to make me host on this one also.
Yes, sir. I can. Yeah, I can.
Okay.
Yeah.
Okay. Okay. Okay, so I think we should get started. So hi, hello everyone. Welcome to this live session. I thought, given the various questions that were raised around week 3 in the discourse forum and various other issues, I think clearly this is a slightly bigger step up than what you have seen in your previous courses. So I thought I should take a little bit of time to maybe convey some ideas on how to approach week 3 and then study from it. Okay, so if you look at week 3, so you're moving to this notion of multiple random variables. Okay. This is a big conceptual jump, and the first idea to appreciate is that some of the statistical phenomena are so complicated that you need really a lot of random variables to describe them. I do in the lectures describe how to do it. So in this, the main ideas to focus on are joint PMF, marginal PMF, conditional PMF. Okay, So these three are important tools and ideas that are needed in this. So I would say to describe multiple random variables, these are very, very useful tools. So now you should be comfortable in so learn basic manipulation of these quantities. So what do I mean by basic manipulation? You may be given a joint PMF. You will have to be able to compute marginal PMF, conditional PMF. Those are basic skills that you need when you deal with descriptions of multiple random variables. So those, I hope, are not very complicated. It's mostly addition, division, simple operations. Usually a small table is given. In small cases, it's very easy, right? In small alphabet cases, small size examples, this is very, very easy. So when will this become a little bit more complicated? So if you start looking at, so some cases are complex, right? So some of the cases are more complex. Some examples involve lengthy computation. Lengthy computations with lots of algebraic manipulation. Okay, so if you're not used to this kind of manipulations, you will start getting nervous, thinking that, oh, you don't understand anything, what is going on, etc., etc. So what I would suggest is these examples are you don't worry too much about such examples. Okay, so these are not something given as the main part of the course. Okay, so these examples need not be studied in great depth. Okay. Okay, so I'm saying great depth. So you don't have to sort of go into every detail of those long derivations. But what is important is, so what is important? Okay, to understand joint distributions. So what is joint distribution? If you have two random variables, they take values together with some probability. Okay, and things like dependence versus independence. This is a very, very crucial idea. Okay, and get a general idea about some shapes and types of distribution. So for instance, if you look at the content of the lectures, the first few lectures probably only deal with small sized example. Towards the end, there are some 3 or 4 properties which maybe involve heavy looking calculations. Okay, and I would say among the properties that are discussed at the later thing, so for instance, the memoryless property of the geometric distribution. If you add two independent geometric distributions, what do you get? If you add two independent Poisson distributions, what do you get? If you add two independent binomial distributions, what do you get? So those are slightly more complicated examples, and to cleverly fully work them out needs this comfort with long computations with algebraic manipulations. And like I said, some of us may be comfortable with it, some of us might get confused by it, etc., etc. But the point of this course, the point in data science is the minute calculations are often not so important, but it's good to know them. I mean, it's good to know that if you do all this, it will eventually work out. But what is more important is the final result. Okay, so make sure that you understand and appreciate how the final result comes. Right, the fact that when you add two binomial distributions, you get another binomial. These kind of high-level facts. When does that happen, right? So it's not like so for instance, if you add binomial n comma p1 and n comma p2, where p1 and p2 are not the same, you're not going to get binomial or anything, right? So if you add binomial n1 comma p, the p is the same. So n1 and n2, and both are independent. If you imagine in your head, it's like, you're doing n1 trials with the same probability p, and then you're doing n2 again, right? And you're adding up the two. Go back to the underlying definition of how binomial is defined using Bernoulli trials. Okay, so that will always help you. All right. So what am I trying to say? So even if you don't understand the lengthy algebraic manipulations, try to think of it a little bit more intuitively. And I think the discourse forum, many people are out there to help you. You raise those questions. So for instance, if you see a lengthy calculation algebraically, which you're not able to understand, you raise a question saying, is there an intuitive way to explain this? And somebody will answer. If nobody answers, I will answer. Somebody will answer saying, here's one way of looking at it. So that will help you remember the result. Okay. And always know the result. Know and remember the results. Okay. Derivations are not so important. Okay. At least in this course. Very important. Okay. If you enjoy them, learn them and like them, but if you don't enjoy them, it's okay. But the results are good to know, and there is always some intuitive explanation most often for these results. And you can always raise a query in the discourse forum, somebody will respond to it, and you can learn from these things. Okay, so take this approach. Like I said, so if you want more concrete examples on how dependence comes and why it's important and all that, we will see quickly later on several data examples where you will see these dependence show up, and we will look at the data, and from there we'll figure out that this is dependent on that. And at that time, we will use joint PMF and marginal PMF and conditional PMF and talk about it. Okay. So in this week, there's not too much of data examples. I think maybe one or two I have here and there, but not too much data examples. But later on, you will have more examples involving some data and some motivation. So in real life, when you look at a lot of data, the first thing you assess is individual descriptive statistics of each data. The next thing that people usually assess is the nature of dependence between different columns of data. Okay, so if you have two different columns of data, how do they depend on each other? Are they independent? If one thing takes one way, when one factor takes one value, does it influence the value of another factor? So these are all described using joint distributions. Okay, so you have to get a good sense of this joint distribution, marginal, conditional, dependence, independence, general idea of shapes. Don't worry too much about these lengthy algebraic manipulations and derivations, but try to appreciate the intuitive nature of the final results that you get. Okay, so more or less that's all I wanted to say. I didn't want to go into a great lesson or anything. Hopefully this should help you relax a little bit. And if you ask me, do you have to spend a little bit more time with this? I will say yes, you have to spend more time. It's not, this is the first time you're learning about multiple random variables. Yes, you will take time, and it's very difficult to pick up and become an expert in all these things immediately after 1 week of study. Okay, so it will take time. I mean, so many of these ideas will be reinforced in your ML Foundations course. You will have an opportunity to come back to these topics again and again and again. Okay, and when you use ideas from here, when you manipulate data and then appreciate how everything comes together, you will have a more clear, grounded understanding. Okay, so be patient, spend a little bit more time, and like I said, don't worry too much about understanding every derivation or worrying about your ability to do those derivations. That you can pick up slowly later, but at least try to understand the results and appreciate them. Okay, so I didn't want to take too much time. It's already about 10 minutes, and you have a session planned as well with the instructors. So maybe I can take 2 or 3 questions if they are on chat. If you can type in your questions on chat, I will see if you have any questions, something that's interesting. I'll see if I can pick up some questions and answer them right now. Okay. Please go ahead and type any questions you may have on the chat window. I can see the chat window right now. If you're typing any questions, I can see on the chat window. Any specific exact questions? Okay, so max and min. Okay. So Kumar wants to ask, but let me just talk about max and min. So I think towards the end, I give a couple of examples of max and min. Yes, max and min are reasonably important. So it's good to know how to work with them in small examples. Okay, so don't worry about large size examples too much. Small sized examples. It's important to fully understand how the small sized examples work. The large size example, at least try to see if you get a flavor of the result and try and appreciate that. But max and min do show up, and having an appreciation of how the max and min works is important. It's okay. Okay, all right. So good. So what we're going to do as part of the course is we're going to float a question in the discourse forum or some other suitable form where we will ask you for 2 or 3 important concepts that you found difficult to understand so far. Okay, and if there is a consensus on one topic, so it looks like max and min is one topic, which is proving to be multiple people are asking for it. So I'll keep this in mind. And you can put down ideas that you found particularly difficult. Try to stay on the conceptual side. Don't ask about one individual derivation that you couldn't understand. That you can ask in the discourse forum. Most people will answer that. If there is a concept itself that you couldn't follow, like for instance, max and min, was it too difficult to understand? There's a difference between small f and capital F. I guess he means CDF and PDF, I think. So what is the PMF and CDF? I haven't actually discussed much about CDF in this class, but anyway, so etc. I think Samit has asked something about, I think Harshit has asked about deriving sum of geometric P and geometric Q. Please ask this question in the discourse forum, Harshit. I think we'll pick it up there. Joint probability calculation. If the 2 random variables not independent with each other and calculation is difficult. Okay, sure. Okay. So max and min is one thing you're asking about. Next is dependent case. Seems to be dependent random variables. You want to do some joint probability calculation. Okay, joint PMF calculation. Okay. So if you have questions like this, I'll note them down. I'm not going to try and answer them now. I will. What I'm going to do is, if to that poll or query that we have on Discourse asking you for 2 or 3 difficult ideas, then if we'll collect all those ideas together, and I will try and create some material, which could be a session like this, or it could be something where I lecture about them or give more examples. I think the most important thing is to give you more problems in those areas, right? So that you get some more experience and build up confidence in that. So we'll try and do this. Okay. Okay. So there is a question on a specific activity question. I think your instructors are very well placed to take this question. So I think I guess there is one person who wants to ask over voice. Okay. So I think if there are not too many more questions on the chat, maybe we can have Kumar ask that question over voice. Yeah, go ahead, Kumar.
Hi, sir.
Yes.
Hi, sir. Good evening. I want to ask about the week 2, some extra activity. Can I ask, sir, from there?
Yeah, sure. Go ahead.
Yeah, sir. It's because I spent lots of time in the extra activity week 2.
Okay.
I get a very interesting conclusion and that time bit of confusion also. The first of all that you have written, sir, example to find the data. I was getting a struggling lot to gather the real world data.
Okay.
And so first of all,
so let me answer it this way. So even if you don't have data, you can give some sort of an intuitive explanation as to why you think this may be dependent or independent, or you can't model that way. Just think of something simple. Nobody wants something very, very complicated. So it can be something as simple as something, anything that happens in everyday life. I'm just thinking of uh, simple real life examples where you may be able to come up with some probability. So don't make it too complicated.
Okay.
It should be something very simple. Okay, and even if you can't come up with data on that, I don't know how you would argue that it's try to see if you can come up with some argument for why some conclusion you're drawing about that data is correct. Okay.
Okay, okay, sir. But and the next thing is there, sir. The question I want to ask that the first example was given that find the test matches in number of test matches play in month is the Poisson distribution or not.
Yeah, yeah.
And for that, I extract all the data from the Greek sheet, sir, and
Okay.
I made a software to calculate all the cricket in the Poisson algorithm.
Okay.
And then I realized one thing that the first test message is there. So I come with one conclusion and I want to ask you, is it right or wrong? The conclusion is there.
So Kumar, I think this needs a little bit more detail. Why don't you post this on the discourse forum? Okay.
Oh, okay, sir.
I can respond there in more detail, looking at the detail that you have. Okay. That's a good example. That's a good example to pick up. Okay.
Okay, sir. I will give.
Okay. So more people have raised their hand. I have about 5 more minutes, so I guess I'll take 2 or 3 questions. This should be okay. How do I find out who has raised their hand?
Sir, Shomit Sen here. Can I ask, sir, one small?
Yes. Yeah. Go ahead. Yeah.
Actually, sir, while I am doing this extra activity for week 0, week 1, and week 2, this is some sort of small project which is basically strengthening my learning part through real modeling the model with real-time data. But while doing this, I am finding small doubt ki why this is happened, why it is not matching in this project itself. So where I can clear those doubts, because I have already
discourse is are you able to post the question on discourse? So see, if you have any such question on particularly on the activities, you please post it on discourse. You will find quite a few people take it up, and I think you can also put some marks there or something, tags there to say you're asking about activity questions. And it should, I mean, are you saying that those questions are not being answered?
No. I am not saying the activity question, sir. I am saying the extra activity.
The extra activity. That's what I meant. Even for the extra activity, you put down something. So maybe Ankur, maybe we can create a separate category under our discourse forum for extra activity. Is there a category like that?
Yes, sir. We'll create one more tag as extra activity. Even they can post it.
Okay, so we'll create a tag, Shamit Sen, on this extra activity, and then you can tag it like that. And I think at least that will bring it to my attention more clearly. Okay,
sir. To that question is relevant only when one can go through my model. But unless and until they studied my model, they're not able to relate these two. So
you should create a nice Colab notebook describing your model, and then link that to the discourse forum, so people will be able to go see it and then comment on it.
If I made this in Google Sheets, only the share will do that. I will just paste it, the share link.
That is also fine. Either Google Sheet or Colab notebook, whatever you prefer to describe your model, you can do. Okay.
Okay. Thank you, sir.
You're welcome. I think Shekhar,
yes,
Arun.
Good evening, sir. Thank you, sir, for giving me a chance to ask question. Sir, I was having one specific question, and that was regarding activity question. In one of the problem in activity question 3.11, at one place it is asked as a find, in another place it is asked as a calculate. So I was little bit confused that in which direction we need to think. First variable Z1 is minimum of 2 random variable X and Y, and Z2 has a max of random variable X and Y. So in one question it asks find f Z1 of 1. In second question it asks calculate fz1 of 1?
Both are same. I mean, find and calculator. You can
But
use them.
answers are given different, sir. That's why I was
No,
worried.
answer is not the same. I meant the
Yeah,
meaning
but
of find and
I did not
calculate.
understand meaning there. That is what.
It's not about the meaning of
Huh.
find and calculate. It's just finding the PMF of max and min. See, the general rule for any functions for discrete random variable is you use the table method. Okay.
Yes, sir.
So the question is on. I keep talking about. I like the table method a lot. It's a very simple method for doing functions of multiple discrete random variables. In small cases, this will work. Small size examples.
Yes, sir.
Always use table method. Okay, so there is a very simple table method you can use. Just make a table. Okay, so make a table instead of writing it as a square block. Supposing you have example, if you have two random variables and so you just write x and y as the values that x takes. I don't know, so maybe 0, 1, 2, 3. Maybe this is 0 and then it takes value 1, right?
Yes, sir.
So maybe just 0, 1. I don't know. Just put like that, and then you write down your fxy of x comma y, right?
Yes, sir.
The joint p. Maybe it's uniform over here, so it's got like 6. So it'll be 1 by 6, 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 1 by 6. Okay, and then you start filling whatever function you want. So if you have a g of xy, you write down the values for g of xy, right?
Yeah.
And then this table pretty much gives you the value for the probability also. Like for instance, supposing g of xy is max of x comma y, right?
Yeah.
So that
Yes,
would
sir.
just take values 0, 1,
1,
2, 1, 1, right?
Yes,
And
sir.
then
Yeah.
supposing you want to look at min of x comma y, it's going to be 0, 0, 0, 0, 0, 1,
0, 1.
right?
Yes,
So now,
yes, sir.
how do you find the distribution? So if supposing somebody asks you, what's the probability that min of x comma y? So first of all, min of x comma y takes values only 0 or 1. What's the probability it's equal to 0? You just have to add up all the cases where 0 happens, add up
Yes,
all
sir.
these probabilities, you'll get 5 by 6.
Yes, sir.
Okay.
Yeah.
Same thing with max or something. So for any function of multiple discrete random variables, small size examples, simply do this. Don't think about any other method. It's just straightforward and easy if you just do this. Okay.
Yes, sir.
And
This is clear. What is the difference then find and calculate?
the same thing. Like
Okay.
I said, just two words we use interchangeably when we ask questions. Right?
Okay, sir.
Is this finding or calculating? I don't know. It's both are the same, right?
Yes, sir. Okay. Thank you, sir. Thank you so much.
You're welcome.
Yes, sir.
Okay, thanks a lot for being in this program. So I'll take leave now from everybody. I hope this was interesting and useful to all, and please enjoy the rest of the session. Ankur is available with you for takeover. Take over, Ankur. Thanks.
Okay. Thank you, sir. Thank you very much.
Ankur, sir. Hello.
Yes, Shikhar. Yeah.
Sir,
Now we can start the session. Yeah.
So do we have the quiz on 30th? Hello.
That is not the date not yet finalized, but yes, there will be quiz. It may postpone a week.
Okay, sir.
I'll confirm with the operation team, and we'll ask them to release one announcement regarding that. Okay.
Yeah, sure.
But
Please,
there's
sir.
a quiz.
Please.
Okay.
Yeah, please do that,
We
sir.
are planning.
It will be really helpful to us. We are in very dilemma that we are not sure whether it is going to happen or not. Yeah, thank you, sir. Thank you.
So can I ask, sir?
I can then understand the feeling. Yeah.
So one particular
Yeah, please go on.
in one
Before just hold on. Before sorry, just one particular, like one thing with everyone. Like, how many of you have solved the tutorials of week 3?
Sir, I did it.
Hello.
Yeah.
Sir, I did it.
You just answer in the chat box. How many of
Okay,
you?
okay. Yes, sir.
So if you have gone through the tutorials, even in tutorials also we have put some examples regarding function of random variable and also min max examples, right?
Yes, sir. Sorry, I will.
Hello. Yeah, and even in the activity question we have also given, I think, 4-5 question that relates with the min max. Practice assignment also we have given one question that relates with the min, right? So have you guys tried that question by solving yourself or posting it on discourse where you got stuck? See, week 3 is all of multiple random variable. You have to practice only. The main confusion is with the symbols, the summation thing. Most of the people have confusion with small f, capital F. So once you start doing practice, you'll get to understand what is the PDF, what is the CDF. Then you won't confuse between the symbols. Most of the people use some different symbol. Suppose that someone write f x y x comma y. For the same thing, people used to write p of x is equal to x, y is equal to y. Okay, once you start doing all these things, you will get a habit, so you won't confuse further. Okay, I'll request to everyone, please go through the activity tutorials practice assignment. Okay, now let's discuss question. Whatever questions you have regarding week 3, we can
Sir,
discuss.
I'm having a question regarding activity question 3.11.
Please.
Only 2 questions I want to discuss. First is a question number 1. I'm not getting, as I asked to sir also. Will you please open up the problem statement? Activity question 3.11.
I'll just share my screen.
Yes, sir.
Sorry, it's taking more than the usual time. 1 second, I'll just refresh it. Yeah, and then have you tried this? What is exact issue regarding that problem?
Sorry, sir.
Your voice was breaking. Will you please repeat?
No, I'm asking you, did you try that and what
Yes,
is
sir, yes. Yes, I tried. I'm having solution for that. At one place, my question answer is not matching.
Hello. Yeah.
Hello, sir. Sir, your voice is breaking a little bit.
Hold on. Just hold on. This is the question. See my screen, right?
So it is not yet loaded.
Okay. Can you present your screen so that I can see the questions? I'm having some issue here. Okay, I'll just give you the access. Okay, you please present whatever you have worked out now. Hello.
Hello, sir.
Yeah, can you present your screen, whatever you have?
Yes, sir. Yes. Sir, it is saying that host disabled participant.
Yep.
Sir, your screen is visible now.
So and the table, right?
So will you give me permission to share the screen?
Hello.
Hello, sir.
Yeah, pardon me. Wait. Yeah. Now my screen is visible.
Yes, sir, it is visible.
Okay. So you have understood the table, right? The joint PMF table, right?
Yes, sir, yeah.
Okay. So now Z1 is defined as the minimum of XY, and Z2 is defined as the max of XY.
Yes.
Right. Now you have been asked to find the value of f Z1 at 1.
Yes.
Right. So this is small. You're clear with this is the PDF, right?
Okay.
Okay. So how will you approach this? Give me some idea. Sir.
Yes, sir. What I did is that, as sir said, na, I converted it into columns.
Mhm.
For x0, y text value 0, 1, 2. For x1, y text value again 0, 1,
Yeah.
2. I repeated that, completed it for x is equal to 3.
Mhm.
Then in next column, I write the minimum of 2. And in next to that, I write the maximum of 2. Where I'm having confusion in a statement that is find and calculate, that I'm not getting. But still what I did is that I just counted in case of find, and in so your voice is again breaking.
Find and calculate both the same thing. I'm saying find and calculate the same thing.
But sir, my
It's
answer
whenever
should be
you have
same,
been
na? But
asked calculate this.
my find of z1 of 1
Yes,
is given
right.
1
You
by
have
3.
to.
Huh.
Okay, so you have difficulty in understanding what is the interpretation of whenever we have find and calculate. Hello.
Sir, the voice is breaking a lot.
Just hold on. Give me 1 minute. Okay. Can you present yours? I think whenever I'm presenting my screen, I'm having issue, connectivity issue. If possible, can someone please share the screen 3.11?
But sir, it needs a permission from your side.
Yeah. You just ask the L grant. Okay, what I'll do one thing. Nikta, are you there in the session?
Yes.
Can you present your screen 3.11?
Hold on. No. No, I can't. It says host disable participant screens sharing.
Give the access. Are you there?
Okay, I'm the co-host. Wait. Can you give me the access?
Wait. I think Karthik need to give the access.
Nikita,
Yes.
can you try now? I just make your cover.
Yeah.
Yeah. Can you try to present now?
Yeah. Done. Which lecture?
Activity question 3.11, ma'am.
Okay.
question number 1 and 7.
Yeah.
At one place it says find for question number 1 and 2, and for 3 and 4 it says calculate.
Yeah, see, even sir had told you like it's the same thing. Like find and calculate are the same thing. You just have to calculate the values.
But in that case, answer should be matching, na? Both answers should be same.
This is small f set 1. That is capital F set 2.
Yes.
Oh,
Correct.
okay. So I didn't pay attention to that part.
Yeah.
Okay. Now it's clear, ma'am. And question number 7.
What I'm saying.
Question number 7.
That can be solved. Yeah, 7.
Yeah.
Ma'am, here, what is the doubt is that once we declare this as a geometric,
Yes.
now Z is a minimum of X and Y. Okay. Then how to proceed? Actually, I was looking for the pair of values of X and Y, which will be giving me joint case of minimum out of 2. But I was not able to solve this, particularly this one.
Minimum of 2 independent geometric will be geometric 1 minus Q. Sorry, I mean 1 minus P1 times 1 minus P2. So
yeah.
at the end of the lecture of 3.11, sir has given one formula, like if you have two random variables that are independent and follows the geometric distribution, then in that case, what should be the formula for min of xy? So you can like find the distribution of min of xy using that formula.
Okay, direct formula we can use there.
Yeah, just try that.
Fine. Okay, I will do that. Thank you.
Okay.
Hello, ma'am.
Actually, I have one question. Just can I ask?
Yeah.
Yeah, actually, in one particular problem, I didn't able to make it. I don't know where I made the mistake. It is the graded assignment, problem number 4.
Week 2.
Week 3.
Week 3. The summation is done.
Not yet.
Not yet, right? Yeah. So we are not going to discuss graded right now.
No, fine. But actually, I don't want that answer. Actually, the concept part, will you discuss or no?
The concept part, like, can you tell me the, like, what is
Graded assignment, week 3, question number 4.
Like, what topic is it?
Okay. Just let me open. It is the problem is a fair coin tossed 4 times, X be the number of heads and Y be the number of heads before the first tails. Okay. Then he is asking f of Y given X equal to 2 at 0.
Yeah. So did you attend the solve with us session for week 3?
Yes.
Yes. So there, I think the question has been taken.
Yes, there I go through that and I take the concept how they approach to that problem. I will try to replicate the same, but I have an answer, but this doesn't match with the option provided here.
Just try it once. Try to understand the, like, go through the YouTube link again. Like, watch the video. Just check. Maybe you are going.
I have just only one confusion. Suppose X and Y are 2 random variable.
Yeah.
And I am putting a joint distribution table, PMF. So say only 2 points, X01 and Y01. So when I am writing this table, the first row, first column, that is 0 point.
Yeah.
In this point, so probability of X is equal to 0 and probability of Y is equal to 0. This is the value I should put.
Where should you put the value?
In 0 cell.
Yeah. If you try to plot the table, so write the table. So yeah, like X
suppose table has two row, 2 column.
Yes.
Row column is 01 and 01. So first cell is 00. So in 00 cell, the value should come probability of X is equal to 0 and Y is equal to 0.
Yes. Yeah.
Right. So when these two random variable is independent, we can write probability of x is equal to 0 into probability of y is equal to 0 individually.
Yes, yes.
So in case of tossing the coin, the probability of getting a head is half and tail is half. So tail is 1/4. So all the cell in that particular table is 1/4 because your all toss is an independent to each other, these two random variable, and I can make this table. Now, if the x and y is, suppose y is now depends on x.
Okay.
So on that time, P of probability of x is equal to 0 and y is equal to 0. I cannot write simply P of PA into PB, right? Then I have to minus P of A into then how can I go about it?
Just let me check the question. I am not getting the idea. Ankur, do you want to say something?
Like, submit what exactly is your doubt, whatever point you made. I think most
So your voice is breaking, sir. I'm not able to hear it.
Hello.
Hello.
Submit. So whatever you been independent, that is correct. If it is independent, as
Sir, voice breaks.
so what exactly is your doubt in that?
Sir, if x and y is dependent variable, dependent with each other, then in joint probability table, how can I calculate that cell? When x taking some value and y is taking some value, and x and y is dependent with each other. Then I cannot do the simple multiplication,
Okay.
or I can do. That is my question, sir.
No, if it is dependent, you cannot do.
Then how to calculate that cell?
Hello.
Hello.
So you have to use their conditioning part, right? There you have to use the conditioning part.
Okay, you are saying कि in those cases you cannot calculate the joint probability table directly, but use the conditional probability and marginal probability to populate that joint probability table. This what you said, sir?
Can use something.
So your voice is very not able to hear.
Can use something like this. I just presented the screen, right? You can use the conditioning part.
Okay.
Hello.
Yeah, okay.
You can see my screen, right?
Right.
Yeah, use the if it is dependent, that means one is dependent on the other. So use the conditioning part. If it is dependent, find the marginal and then find the, okay, now the sample space is reduced. What is the value of that? Okay.
Okay.
Yeah. Oh, hello.
Hello, sir.
Yeah, hello. Dibyantu. Yeah, hello.
Sir, your voice is very low. Not able to hear you.
Okay. Uh, okay, what is it?
Hello.
Hello, ma'am.
Hello.
Yes, yeah.
Ma'am, 3.11 question number 3 or 4. Can you solve one of them? How to calculate the capital F Z?
Just hold on.
Okay, ma'am.
Nikita, wait, I'll just solve the question. Just let me know if my screen is visible. I'll solve the questions. Okay. Hello.
Yes, sir. It is visible, sir.
Okay, thank you. Yeah. Just hold on. So question number 3, right?
Yes, sir.
Okay. So it is. This I have to use. So it is for one. Can you guide me? Like, whatever I'm saying, if it is all to you, just let me know. We have to find f of z21, right?
Yes, sir.
Hello.
Sir, your voice is breaking too much.
Is defined as the is z2 is defined as the maximum, right?
Right,
Correct.
sir.
Okay. So when you say f of z2, this is nothing but you can make small f small f. Max, comma, now you have to check from the table.
Okay, so for both of x and y less than or equal to 1, I have to check.
Yes. So now x is taking value.
Right.
X is taking value 0, 1, 2, 3, right?
Right.
Y is taking value 0, 1, 2 or 3 also.
No, sir, only 2, up to 2.
Okay, this is correct, right? Whatever I have written.
Yes, sir.
Okay, now you have to see for each pair. Okay, for
Which,
each pair when this is true.
okay.
So, hello.
Yes, sir. So your voice break.
So I'm saying that if you pick 0, 0, this is true or not?
Yes, it is true. True, sir, it is true.
Okay.
So only 4 cases are there. 0, 0, 0, 1, 1, 0, and 1, 1.
Okay. So can you check the probability corresponding to that value and add?
Okay, sir.
Okay, just do it. What is the value you're getting?
4 by 12, 1 by
Okay,
3.
that is 1 by 3. Okay,
Right,
and
sir.
what is the answer in that?
That is also 1 by 3.
Yeah, correct. Same you can do with the min case also.
Okay, sir.
check with the table. So see, whenever you have these type of problems, just try to simplify the expression. Okay, once you have the simplified expression, try to relate it with your table. So check for whatever values these relations are satisfying. And once you got that, add the values which correspond to that pair. You'll get your answer.
But for the question in question number 2,
Yeah.
that is small f z2 of 1, that is also doing the same now.
Yes, correct. But that is the minimum, right? Sorry. Okay, this is already f of z21. So it should be max of x comma y should be 1, not less than equal to 1, right? So one pair will be
the 0,
exempted.
0
That is
pair will not be there.
correct. So that is 3 by 12. So 1 by 4, right?
Okay, sir. Thank you, sir.
Yeah.
Sir, in a joint probability distribution, suppose f of xy, it varies, means it is independent or dependent. We can check this through as our test that whether the conditional probability is the joint probability is f of x into f of y or not. With from this statement I can check, right?
Yes.
Yeah, voice is saying.
So basically, what you have to do, check if
So,
this is possible.
so your voice is breaking, sir.
Wait.
Navid, if in the meanwhile, if you can mention, yeah, you have to do that for every case, right? Every joint value of x and y, you have to prove that the joint is the product of the individuals. So then we can prove. So to prove independence, you have to look at every case. To prove dependence, it's enough if you just take it one case and say that they are not equal.
Okay. So when we are calculating the marginal PMF, then what we generally do, we fix one, vary one, and then sum the other one, marginalize the other one, right?
Yes.
Okay.
Yeah. Anyway,
So
sir is also showing you how do you calculate independence, right? So for all xy, so that is how we are doing.
Yeah. Suppose I want to calculate the marginal PMF of x. So what I will do, I will fix the x as a constant and sum the range of y onto that joint probability table, right? So fix x and calculate the summation of for that particular y in a total column, right?
Yes, correct. Yes.
Acha. In this case, if suppose the value of x and y both needs to be changed. I mean to say, suppose it is given, I want to multiply a factor which is applicable for x and y both, but since I am fixing the x as a constant, now the multiplication factor will do only with y, or it will be applicable for both x and y.
So depending on what are you finding, right? If you're finding the marginal probability corresponding to the value of x, then you have to run through all the values of range in y.
So in this case, yeah.
So before this also in part 1, in the week 6 or 7. So let's forget about this random variable also. So just to define the probability on event, simply event. So when you do the conditioning part, okay, the sample space reduces itself. Now you have to, whenever you, let's say, multiplication rule, there you use multiplication rule. Okay, finding probability, x belongs to this set A, y belongs with this set B. Okay, there also you used to do, right? whenever you have to find corresponding to x, you run through all the values of y, and you can find the
Ankur, you're not audible.
yeah. Yeah, so hello.
Your voice is breaking.
So Anita, I think Sumit, I've understood right. Or do you more clear on that?
Ankur,
I'm not,
can you write it on the chat box? I will check there.
ma'am,
Yes.
in Poisson distribution,
Yes.
what we calculate, basically we calculate a particular number of events occurred in a particular time interval. This what we calculate. Now in this scenario, if both means x and y, two random variable is varying and a joint probability table is given. Now when I try to factorize this time interval, say suppose I am taking the data from every hour. Now I want to calculate the data for every 2 hours. Then the joint probability table will also get multiplied with 4 or with 2.
Sorry, I didn't get you.
Suppose
Yes.
in Poisson distribution,
Yes.
suppose in 1 hour time
You have,
interval,
okay, you
I'm,
have calculated for 1 hour time interval.
now if I want to calculate the marginal PMF for any either x or either y, anyone, now for 2 hours interval, suppose. So in that particular time, when I summate this joint table, then I calculate multiply with 4 or multiply with 2.
You have how many? You have two random variables.
2 random variables. And for these 2 random variable, there is a joint probability I have calculated in 1 hour time interval.
Yes.
And I have the table with me.
So if you want for 2 hours time interval, if for lambda will be 2, like if, then your answers will change. It's not like you have to multiply by 2 or 4 to the probability.
And also, Samit, hello.
No,
Can you hear
in
me, right?
in 1 hour time interval is 5 cars arrived. In 2 hours time interval, suppose a Poisson distribution is given to me, and saying this every 1 hour time interval, this data has been collected. Now, if I want to calculate from that given data a marginal PMF, because that is given for two joint PMF, then the joint PMF value will have a multiplication factor, or I will not able to do it. I didn't get that.
Samit, can you define your x and y here? What is
Sorry,
your x
sir.
and y?
Suppose
Can you define your x and y?
x and y, two random variables, sir. Suppose.
Okay, random variable.
I mean, both are Poisson.
You mentioned.
Hello.
Sorry.
Are both random variables Poisson?
Both random variables are Poissons.
Okay, and what they are doing?
They,
let's say I mentioned that number of car accident on a highway is modeled as a Poisson distribution. I want that thing. So your x is Poisson. That part I understand. What
sir,
is x and y actually doing?
X is Poisson and y is also Poisson. Suppose I am saying the number of accident for every hour. In number of accident, this accident I split. X is having minor injury and y is having major injury. Okay. this I calculate in every hour data and populate my joint this PMF table, where the X is a random variable which is denoted as minor accident and Y is a random variable denoted as major accident. Now, if I from this table, if I want to calculate the say minor accident for a time interval, since both are poisons, but this time I want to calculate with 2 hours interval, then my joint probability table will multiply by 4 or multiply by 2 while I am calculating this marginal one.
No, you are calculating the marginal, right? So you have to calculate the marginal first and then you have to multiply.
Multiply with what? Right. Multiply with 2 or multiply with 4?
If you are saying 2 hours, then you have to multiply with 2.
Since I am varying only one random variable, that is the logic.
You are saying now, see, initially X was here, you are observing minor in 1 hour time interval. Now you are observing minor injury in the next hour interval. Forget about the Y here. Okay, so you have 2 time interval. In one, what was the average? In the second will be twice. Because if like whatever minor accident you have in the first interval, that will be independent of the other. So you have to multiply it by twice of the average for finding it both.
But since your voice get break, many things I didn't hear what you said.
So for poison, see, it's for calculating 2 time intervals, and that mostly poison does not affect like whatever event in the interval, whatever event occurs in the second interval. So they both so mostly it will be independent. So whatever you have in the first, you have to multiply it by 12. If it is independent, if not, you have to go through the formal process.
Sir, not able to hear because voice get break, sir. Not able to hear anything.
Nitin, Nitin, can you take his question?
Hello.
Yeah, Samit, can you explain your question to him?
No, question is, ma'am, in every time interval, suppose 1 hour time interval, I am collecting data, the accident data. In accident, there is a splitting, minor accident and major accident. So every hour, I am collecting this data and populate my joint PMF table with X as a minor accident and Y as a major accident. So this is given. I am having this with me. Now, if I want to calculate the marginal of minor accident, but in 2 hours time, is it possible to calculate for me? First question is that data is collected in 1 hour, but can I calculate this from this joint distribution table, which is made by 1 hour data interval, and now if I want to calculate the marginal PMF from that joint PFF, but the interval time is now instead of 1, 2, can I do that?
Yes, Amit, you can do that. For 1 hour time period, you have given the joint PMF of X and Y, right?
Right.
Now you have to find the marginal of X within that 2 hour time period.
Yes.
So you just need to add the joint probabilities of X, X and Y in those two time period.
But here, sir, when I am calculating one marginal PMF, what we generally do, we fix one and vary others. Then suppose I want to calculate X, I want to vary the joint PMF value throughout the Y, but fixing the X. Since I am now multiplying with 2, So shall I multiply?
Look. First, tell me what does marginal denote?
Marginal.
You have two random variables x and y, right? And you have the joint PMF of those two random variables.
Yes.
Now, what does the marginal PMF of x will denote will represent?
Marginal PMF of x means at any value of x given, that value of x is constant. Now, taking that value as constant, I am varying the y value and summation.
Yeah, just like in your case, x and y will take values from 0 to infinity, right? Both the variables will take values from 0 to infinity. Now, for marginal, you have to find the probability that x will take value 0.
Yes.
Right. So for 1 hour time, you just calculate for 1 hour time period. Once you have calculated for the marginal of x into 1 hour time period, you can calculate for different time period by just varying the lambda. Lambda is if x and y Poisson in your case, then you have to just vary your average within that time period. Like if you have lambda is equal to 2 for 1 hour time period, then lambda will be 4 in 2 hours time period. The same formula will be applied there. Just marginal you have to find for x within 1 hour time period. Marginal will denote what you have to find probability that x will take value 0 or 1 or all that individual outcome you have to find. And how you can find that? To find that, you have to just sum over all the possible values of y.
Yes, all the possible values.
And you just pick the value of x at that particular observation. Okay.
Okay, sir. Okay.
Hello, sir. Hello.
Thank you, Nitin. Hello,
hello, sir. Hello.
Yeah, Shumista.
Yes, ma'am. Ma'am, I have some doubts in activity question and in tutorials.
Yeah, okay. Can you tell your doubts?
Yes, ma'am. First, activity 3.11, question number 6.
3.11, question number 6. I think we discussed this question 2 minutes back.
No, ma'am. That was question number 3.
Question number 3. Okay, yes. What is the doubt there?
Ma'am, what will be the approach if z to 2? That means cumulative distribution for f at z2 equals to 2, right?
Yeah, and what is Z2?
Z2 mean of x1 to x10.
Yes.
So, ma'am, we have to calculate probability of x mean of x1 to x10.
Yes.
Lesser
Less than equal to?
Lesser equals to 1.
Less than equals to 2.
2. Sorry, 2. Then, ma'am, we have then if we calculate 1 minus p of probability greater than 2, that will be fine.
Sorry, if you calculate
1 minus probability greater equals to 2.
1 minus probability greater than equal
to 2. That will be the answer.
No, that will not be the answer. So see, you have 10 random variables IID binomial,
Yes,
6 comma half, and you have defined Z2 as min of x1 to x10.
Yes.
So if you have to find f of Z2 comma 2, so just what is that? P of min of x1 to x10 greater than 2. And now you know that, so see, min of x1 to x10 should be greater than 2. So all of the xi should be greater than 2. Okay, when you do it, min of, you have to calculate min of this less than equal to 2. Now you calculate first min of x1 to x10 greater than 2.
Okay.
So if min of x1 to x10 is greater than 2, it means all of xi's will be greater than 2, right? If minimum is greater, so all the xi will be greater. Now, all the xi's are IIT binomial. So we can write all those xi's as x.
Yes.
Right. So
Right, ma'am.
now what we have is we can write it as probability.
Ma'am,
X
if
of,
you
yeah.
can write it, that would be very helpful.
Okay. Just hold on.
Nikita, which question?
This is question number 6. Do you want to explain? Yeah, you can see my screen, right?
Yes, ma'am.
Yeah, so you have x1, x2, x10, IID, binomials, 6, right? 6 or something else. What is that?
6, ma'am.
6 comma half. Yeah.
Half.
6 comma half. Now you have to find f of z2,
Z2 equals to 2.
So this is p of z2 was min. So min of x1, x2 up to x10 is less than equals to 2. So how will you approach this? You like just first write p of min of x1, x2, x10 greater than 2. You find this. Okay.
Yes, ma'am.
So this will, if
1 minus.
Yeah, so if let's say it is 2 and min of all those xi are greater than 2, it means all those xi's are greater than 2. Right? So this
Right,
will
ma'am.
p of x1 greater than 2, x2 greater than 2, up to x10 greater than 2. Now these all are IID binomial, so it will be p of x greater than 2 to the power 10. Right?
Right, ma'am.
Yeah. So that you can write as, so this will be yeah, so sorry, it is this is probability x greater than 2 to the power is whole to the power 10. Now what can you write p of x greater than 2? You can write it as 1 minus p of x less than
equals to 2
to the power 10. And what is x? X models the binomial distribution, that is a binomial 6 comma half. So you just substitute the values of x. You have to find p of x less than equals 2. So this is x can take values 0, 1, 2. You find
Yes, ma'am.
x0 plus probability x1 and probability x equals 2. So you
Correct,
just
ma'am.
find this probability and substitute it here.
Okay, ma'am. Okay.
Ma'am,
Got it.
Yeah,
ma'am, it is giving
yeah, it is
22 by 2 to the power 6. 1 minus 22 by 2 to the 6.
it will give you the answer 1 minus 21 by 2 to the power 5 by 10, I guess.
But how, ma'am? Ma'am, x is equal to 0 is 6 is 0 into half to the power 6, right?
6 is 0 is 1.
Plus 61 into half to the power 6.
Wait, I will calculate. So 60 half 6. 61 half 6 minus 6 plus 62 half 6 all to the power 10.
Yes, ma'am. It is 1 plus
1 that will come out to be 1 minus
1 minus
yeah?
1 plus 6 plus 20, 15, right?
So it will come out to be 1 minus 22 by 2 to the power 6 to the power 10.
Yes, ma'am.
Right?
Right, ma'am. But the answer is 1 minus 21 by 2 to the power 5.
Actually, there is a slight change in the answer. Like the answer that is given is wrong. That is on the portal is wrong.
Okay, ma'am.
Yeah, it'll change it. So one extra bracket is there that need to be removed.
Ma'am, it is 22 by 2 to the power 6, right?
Yeah, it is coming out to be 22 by 2 to the power 1 minus 22 by 2 to the power 6 power 10.
Okay.
Nikita.
Hello.
Just hold on. I have done some work, so I'll share my screen. Okay. Yeah.
Okay.
Wait. Okay. Is my screen visible to everyone?
Yes, sir.
Okay, so now you can see if you have any doubt in any step, just let me know. If you solve the last step, you will get 1 minus 1, that is 64 minus 22 upon 2 power 6 power 10, that is 1 minus 42 by 2 power 6, that is nothing but 1 minus 21 by 2 power 5 power 10. Yeah. Nikita.
Yes, uncle.
Am I audible, right?
You're audible.
So all of you can see the solution. All of you can see the solution. If any doubt, let me know. That last step, when you do, you'll get, hold on, just I'll write the
1 minus 42 by 2 to the power 6 to the power 10.
But ma'am, when z is minimum of xy,
Sorry.
When z is defined as minimum of xy,
yes,
then shouldn't be the probability of minimum x1 up to x10 greater than or equal to 2?
Which one greater than equal to?
Ma'am, the first line.
Yeah, first line.
It is the capital F of z bracket 2, right? Then
yeah.
And then it is probability of minimum of x1 up to x10.
Yes.
Should it not be greater than or equal to 2?
If you have been asked Z1 less than equal to 2, right? And Z1 is defined as the minimum.
But sir, it is Z2. Capital F Z2.
Yes, that is a typo mistake. Z2 only. Z2 is defined as min of x1 to x10.
Yeah. Oh, here will be. Yeah.
Sir, can't hear you properly.
You can do this, right? If you have
Sir,
doubt
can't
in
hear
it,
you.
let us.
If any of you has doubt in this explanation, you can ask.
Okay, ma'am.
Just go through it, like see, look at all the steps.
Screen is not visible.
Uncle, okay, I think he got cut. Oh, just hold on. Any of you wrote it down? I think, yeah, he joined again. Ankur, can you share the screen again?
Yeah, just hold on 1 second. Today, because of the this is the solution. This is right.
Yes, sir, it's visible now. Okay, sir, got it.
You all have understood. Okay. Should I stop sharing my screen? We
Yes,
move
sir,
to
yes.
next question.
Yes, sir. Sir, next doubt is tutorial 1, question number 3.
Tutorial 1.
Yes,
Can I
sir.
ask a question?
Okay, go on. Till then, I'll just open tutorial.
I was saying that like in the week 2 extra activity, I have done the activity like using Python. Like I have calculated the whole PMF using Python and like done the using polynomial regression. I fitted that thing.
Okay.
Is it valid?
You fitted with polynomial regression. I didn't get that part.
PMF was showing a polynomial trend. Okay. So I
Okay.
fitted the X train with polynomial and checked with X test.
Okay, but make sure to check your polynomial regression fits the PMF.
Yeah, I have plotted y test versus y test versus y prediction, and it was most of the points were on a straight line.
Okay. Uh, yes, it is. But make sure it fits the model, right?
Pardon me?
Just make sure it fits the model. Just check
Yeah, it is fitting the
point
model.
which
Yeah,
you
it's fitting
verify.
like it's fitting the model. Yeah. Okay.
Hello.
Hello, sir.
Yeah.
Hello.
So you said tutorial.
Yes, sir. Tutorial.
What is the question number? Can you repeat, please?
Hello.
Yeah. So which question you are talking about?
Yes, sir. Question number 3.
Okay, 3. Hold on. Okay, and what is your doubt?
Sir, I can't approach it. What will be the approach? How to figure out it?
You don't know the solution for this.
Yes, sir.
But I also, right?
Yes, sir. But I can't understand it. Please explain.
Okay. Hold on. Okay, you understood random variable, right?
Yes, sir.
X denote the smaller 2, so like whatever number, like pair of number.
Yes, sir.
So X, you got the range of X and Y, right?
Right, sir.
So now you
Hello, sir. Sir, can't hear you. Hello. Hello. Hello.
Yes, Sumista, just hold on.
Okay, ma'am.
Yeah, he got.
Hello.
Yes, sir.
Can you explain question? And explain.
Sir, your voice is breaking.
Your screen.
Yes, just let me check the question.
Yes, ma'am. Go on.
Yeah, thank you.
Hello, ma'am. Hello.
Yes.
Okay,
I'm
ma'am.
just waiting for Ankur.
Okay.
Yeah.
Ma'am, just one question in between. Hello.
Yes.
Suppose two random variables are there. If they are not independent with each other, then can I conclude that they are dependent with each other?
Yeah, if they are not independent, they are dependent.
Okay. And in Poisson's ratio, means Poisson distribution,
Yeah.
generally, if that is nothing is mentioned, then we take x from 0 to infinity or 1 to infinity.
Where in Poisson distribution?
Yeah.
0 to infinity, because you are interested in number of successes, so it always goes from 0 to infinity.
Okay. Unless if there is a mention key, this varies from 1 to infinity.
Yes, unless it is mentioned in the question.
Okay.
Yeah. Yes, Miss.
Yes, ma'am.
Yeah, Ankur will take that question. Do you have any other question?
Yes, ma'am. Next question, tutorial 1, question number 4. That also I can't understand.
4. Oh, it's on the same line.
And my next question is tutorial 2, question number 12.
So question number 12.
Tutorial 2.
Okay. See, tutorial 1, if you go, tutorial 1, question number 4, you have already calculated the joint distribution in question number 3. So the joint distribution in that case was like for x less than 1, that's 2 by n times n minus 1. Now you have to find the marginal of x. So to find the marginal of x, you just have to
But ma'am,
over.
I can't do question number 3. For why I can't
After
also.
that, after that I'm telling you, like once you get that,
Yes,
like
ma'am.
what you have to do in question number 4. So you
Yes,
just
ma'am.
have to sum it over y value. So because you have to find the marginal of x. So y is
Correct, ma'am.
the value from 2 to 3. So fx of 1 will be, you look at the column 1. So it is 2 by n times n minus 1. It will go till, it will vary from 2 to n. Right?
Yes, ma'am.
So that is total of, so if you look at the y column, it varies from 2, 3, 4 up to n. So this is total of n minus 1. So you have to add 2 divided by n times n minus 1, n minus 1 times. Right?
Sorry, ma'am.
You didn't get that?
Yes, yes.
See, if you look at the table, so in the column 1,
yes,
y is varying from 2 to n.
Correct, correct.
2 to n. So how many numbers are there from 2 to n?
N minus 1.
N minus 1. So to find fx of 1, you have to sum the numbers that is in column 1. How many times?
N minus 1 times.
N minus 1 times. Now you look at column number 2.
Correct.
So here x and y will not, x2 and y0, y2 will not take any value. Like probability is 0 in that case.
N minus 2 times.
So you have to, and for the remaining, it is again 2 by n, n times n minus 1. So that is n minus 2 times. If you
Correct,
sum it over, it will be again, so you just have to sum it. So it is, so the first was 2 times n minus 1 by n times n minus 1. Next will be 2 times n minus 2 by n times n minus 1. You have to go on like that. So for some general k, it will be, you have to sum 2 times n divided by n minus 1, n minus k times.
Yes, ma'am.
Right? So
right.
So that's it. That was the question.
Okay, ma'am. Right, I got it now.
So what is your k? K is your like y. So y is taking like 1 to, there are total of n minus 1. So k will take the value from 1 to n minus 1.
Right, ma'am.
See? Okay, Ankur is sharing the screen. Yes.
Okay.
Ankur, can you explain question number 3?
Hello.
Yes, Ankur.
Nitin will explain the question. Nitin, I've just presented the screen. Just explain the
Hello.
question.
Hello, sir.
Hello.
Hello, sir.
Am I audible?
Yes, sir.
Okay, so in this question, what you have to find, you have given 2 random variable x and y. Okay.
Yes.
Now what you are doing, you are drawing 2 walls randomly. two tickets, sorry. Okay, number from 1 to n. Now, in those two tickets, one is smaller and another one will be the greater than 1, right?
Right, sir.
Yeah, so the smaller one you will give you will assign it to the x. That is, x will take that smaller value and y will take the bigger value.
Correct.
Right. In the doesn't matter in what order you have picked those tickets. If you
Right,
let's say you have chosen 2 and 5. Ticket number 2 and ticket number 5.
So x equals to 2, y equals to 5.
Yeah, doesn't matter you pick 2 first or you pick 5 first. So
Correct,
what are the possible probability that you picked ticket number 2 and ticket number 5? That is, there is only one ticket number 2, right? In the n tickets. So probability of that will be 1 by n. Once you have picked that, the probability of picking second ticket will be 1 upon 1 upon n minus 1, right? That's 5 number ticket, right? But the order can be changed. You can pick 2 first, you can pick 5 first.
So
doesn't
there
matter. In both the cases, x will be 2 and y will be 5. Right? So that's in that way, choose any x and y where x is less than equal to y. The probability of x y will be 2 upon n into n minus 1.
Right, sir.
Is it clear?
Yes. So, sir, please explain again why n into n minus 1?
One way to look at this, you just make the table where you put the values of x and y from 1 to n, and if you don't go to n, just fix
There
three
are
numbers,
n
3
into
or 2
n
numbers to
minus 1
simplify.
total number n into n minus 1, and we
for
yes, sir. And two numbers are those types.
Sorry.
Total n into n minus 1 numbers and two numbers satisfy our condition. For y, 2 by n into n minus 1.
Yeah, that probability is 2 upon n into n minus 1. But what you said, total number n into n minus 1?
There are total number.
I'm just finding. There are total n tickets.
Right, sir.
Okay, I'm just finding the probability of choosing. Just fix x and y. X and y are my two numbers from 1 to n. Then you have to find the probability that you choose number x and y. You are picking two tickets.
Yes.
Without replacement. So what are the possibilities that probability that you will pick number 2, ticket number 2 and ticket number 5? That you have to find probability. So what is the probability to picking ticket number 2? Only ticket number 2 is there in all n tickets. That 2 and 5 I'm giving just example to you.
Yes.
It's true
so
for
1 by
any x
n.
and y.
1 by n.
Yeah, that will be 1 by n. Once you have picked ticket number 2, now you have remained with n minus 1 ticket. So what is the possibility? Then you will pick 5 number ticket from that n minus 1 tickets.
1 by n minus n. 1 by n minus 1.
Yeah. So that will be a probability. But you can pick 5 first, 2 first. In both order you can pick.
Yes, sir. Yes.
In both the cases, x will be 2 and y will be 5. Because
yes, sir.
That's how I define my variables.
Right, sir. Got it now.
Hello,
yes.
sir. Hello.
Yes,
sir. Why the range of x is up to 1 to n minus 1?
Because
x is smaller number. Right, sir?
Yeah, smaller, and you are picking without replacement because you cannot have both n number tickets in your end to you, right? If it is the case with replacement, then it can go up to n. But you are picking without replacement, then whatever the case, it cannot smaller value cannot be n.
Because if we put x equals to n, then y equals to nothing.
Sorry, x is equal to x
n,
cannot
then
take
y,
value n.
Yes,
X cannot take value n.
Then there will be no maximum value.
X, I think, is a smaller one.
Yes, sir. Right, sir.
So
got it now.
X cannot take n. Yeah. So range of x will be 1 to n minus 1, and range of y will be from 2 to n. That's clear, right? So one way to do that, just pick n is equal to 2 or 3 for and then do for the table. you get much better idea about it.
Yes, sir. Right.
Okay.
Okay, sir. Next, tutorial 2, question number 12. Hello, sir. Am I audible?
Yeah, Ankur.
Hello.
Hello.
Yes, yes, you are audible.
Yeah, you are audible, but Ankur is not listening.
Hello.
Yes, sir.
Yeah, Nitin, you were saying something? Hold on, just hold on.
Yes, he's asking some question, please.
Okay. Okay. What is the question? Okay, can you
So,
repeat, please?
tutorial 2, question number 12.
Tutorial 2, question number 12. Hold on. Okay, and what is your doubt in this?
So, I can't approach it. Please explain properly.
Okay, hold on.
I saw feedback, but I can't understand.
So, you have number of people who visit a dance academy each day is a Poisson random variable with mean lambda. Each person who visit independently, female with probability P or male with probability 1 minus P, find the joint probability that exactly M men and W women visit the dance academy on any particular day. Okay, let's go to the feedback. X denote the number of women and Y denote the number of men who visit the dance academy on any particular day. Okay, so
Sir,
X
are you
plus Y will be the total number of people who visit, right?
Right, sir.
Yes.
Now it's visible.
You can see my.
Yes, sir.
Okay.
Yes.
Answer
So
D is correct,
the
right?
total
Answer D is
number of
correct.
people will be the sum
So
of
answer D is
number
correct,
of.
right?
Sorry.
The last option is correct, right?
Hello. Yes. 1 second. Yes. I have to check the answer.
Because it is showing incorrect, though we have selected option 4.
Okay, then that would be the some configuration issue. I'll ask them to modify it. If you see whatever is in the feedback, it's correct.
Yeah, so it's
Okay, sir. Then it's right. I understand this.
Okay.
Okay,
Then
sir.
I'll
Now
ask
it's.
him to update that. That is the configuration.
Yes, it's
Okay.
showing wrong option. Sir.
So activity 3.11, question number
Sir, practice
5.
assignment.
3.11, question number 5.
Sir, I have doubt in practice assignment.
I have released the practice assignment. What is your doubt?
Yes, sir.
Yes,
Practice assignment question number 6.
Question number 6.
Sir, in assignment solution part, why it's multiple by 25 and 26? I can't understand that part. If you calculate it, that would be helpful.
Wait. Question number 6, right?
Right, sir. And sir, also in practice assignment solution
and
part,
what is
all questions and answers are shuffled. It's not matching with practice assignment question.
Okay, that PDF and the configuration on the portal you're talking about.
Yes, sir.
Okay,
Sir,
that I'll check. Wait.
Okay. So, sir,
Okay,
practice
so
assignment
what
question
3.11
is
number
your
question number
doubt?
6.
5. So can you tell 3.11 question number
Uh,
5?
Priyanshu, hold on. I'll explain your question before winding up this session. Don't worry. I'll be here. Okay, don't
Okay,
worry.
okay.
I'll come to your question. Yeah, yeah. Okay, and what is your doubt in question number 6?
Sir, I apply geometric, but it's not. I got a step that's like 1 minus p whole to the power 24 greater than 1 minus p whole to the power 23. But if when I put the values that's given in these options, then I get p equals to p greater than 0.04. But from this equation, I can't solve it.
Okay, you're talking about, okay, question number 6.
Yes,
Okay,
sir.
so the
Here
configuration,
it's question
so
number
on
4.
the portal, the question number, yeah, I got your point regarding that numbering issue on the portal. See, the question number 1 has 3 subparts. So that on the portal is listed at 3 questions. That's why the number
Okay.
difference is there. Whatever
Okay,
you
sir.
are asking, that is question number 4. Yeah. So what is your doubt?
Sir, here when I solve this part, I get equation 1 minus p whole to the power 24 greater than 1 minus p whole to the power 23. But in this
Okay.
solution part,
One
it's
power difference you're
multiply.
getting. Okay. Can you share your solution, whatever you have done, so that I can see? Otherwise, see, when you find out the probability x plus y is equal to n, you will get this PMF. You'll try, you'll get.
Sir,
If you want, I can post it on Discourse also, whole derivation.
sir, p of z equals to 26 means x equals to small x and y equals to 26 minus x, right?
Yes, correct. Yeah,
So
yeah.
yes,
In that way, you can
so
proceed, right? Yeah.
so that means it is p of x equals to small x into p of y equals to 26 minus x, right? Because it's independent.
Okay.
And p of
Yeah.
x equals to small x, that is geometric, so that will be 1 minus p whole to the power x minus 1 into p.
Okay.
And p of y equals to
Yeah.
26 minus x, that part will be 1 minus p whole to the power 26 minus x minus 1 into p. And from this calculation, we get 1 minus p whole to the power 24 into p squared.
Can you post your whatever you have worked out on Discord?
Okay, sir, I
so
put
that
it
I can
on
take a
chat.
look? Okay, so you want me to? Okay, wait.
I will put it on chat.
Hello, sir.
Okay. Yeah.
So she is asking about the numbers 25 and 24 multiplied to both of it.
Okay, so according to her, it won't be here, right? Something like this.
Yes, sir. I think she wants to tell that.
Okay, you just post it on Discord.
Okay, Ankur, I do.
Yeah, Nathan,
Hello.
go on, please.
Just share your screen. That question I will explain it.
Actually, I also see this solution in discourse where Nitin sir maybe solved it.
So you didn't get there?
Yes, sir. And from there, I got a equation 1 minus p whole to the power 24 into p square greater than 1 minus p whole to the power 23 p square. And both side p square is cut, and I get 1 minus p whole to the power 24 greater than 1 minus p whole to the power 23.
And you are not getting 25 and 24 as the coefficient there.
Yes, sir.
You are not getting that.
Yes, sir. Why 25
Okay,
and 24?
So just explain me whatever you just explained. How you are finding probability of z equal to n? Z is x plus y. So what you did, you just multiplied p x is equal to x into p of y equal to 26 minus x.
Right, sir.
But
Right.
what are these x, small x?
Value of x
Value of
random variable.
x random variable. So how you have to vary all for such values where you can get x plus y equal to 26, right?
Right,
So
sir. Right.
yeah. So x will x is taking value from 1 to infinity, but whenever you go greater than 25, then y will be 26 minus 26 or 26 minus greater than any number to 26, right? So that will give you negative value for y. And y is not defined for negative values.
Right.
So x will vary from 1 to 25 only.
Okay.
So 25, and if you look in the summation, inside the summation, this is the constant because this is the some power to p, right? It is not varying on x. So you can actually, what you are doing, you are adding those terms 25 times. That is,
Yes,
whatever
sir.
you are getting 1 raised to power some x minus 1, something like that. You are adding like that, right? So that is constant and will give you 25 into some p square or something like that. You have to, I don't exactly remember, I have to look at that. So that you will get by adding all those terms.
Okay.
Just vary x, because this is not just single x. You have to vary x over all such range, such values of x where you can get x plus y equal to 26.
Okay.
And in the same case, you can do for z equal to 25.
Okay.
Okay.
So, sir,
So
how
from
to
there,
vary this?
no,
Explain again, please.
you are fixing x equal to small x, right? Now these x are in the range of x, and x can take value 1 to infinity. Right? But whenever you are fixing x equal to x, y takes value 26 minus x.
So x will be from 0 to 26.
25, because at 26 it goes 0, y goes 0.
So why if x if x takes value x equals to 0, then why not y equals to 0?
No, x is not taking value 0. X is starting from 1. X is geometric and y is geometric.
Yes. So, yeah,
So
maybe x
range
equals
is
to 0
starting,
and y equals to 26. That also possible.
no. If it is not mentioned that it is taking geometric takes range from 1 to infinity. Otherwise,
But sir,
if it is not mentioned.
But somewhere.
That in different contexts it can take 0 as well. But if it is not mentioned or it is not given that range is starting from 0, you have to assume that geometric takes value from 1 to infinity, right?
Okay.
If some context is given, like the number of heads before first tail, then in that case x can take 0. But if it's not mentioned or any context is not given, then you have to assume that geometric takes range from 1 to infinity.
Okay.
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 And
so for that, okay. And now I got it.
And also for reference, if you want to derive general thing, take the reference from question number 6, week 3 tutorial 1. Go through the similar line you will get for general thing.
Yeah. So whenever you are calculating that summation part, you have to check you have to take care of their range.
Okay, sir. Okay.
See here, this part. So based on the similar line, just make it here positive and proceed. You will get a general equation for that.
Okay, sir. Yes. Right. Now I got it.
Yeah.
And sir, practice assignment 13.
Wait. I think someone was asking activity. 13 question.
Yes, sir. Can I ask?
Yeah. Yes.
Hello.
Yeah. Please ask. Yeah.
Sir, I was having question in activity 3.11.
Okay. Which question?
Question number 6.
Question number 6, I just discussed, right? I presented on the screen also.
Activity 3.11 only.
Yeah, I'll It's not even, it's on my screen. I'll just share my screen. You can take a look.
Sir,
It's visible, right? It's visible to you. Yeah.
yeah, sir, I had a question that, sir, when we have to find the minimum, we write it as greater than 2. We write it greater than 2 and we have to find the minimum, right? So and in the question you have to find that f z2 as 2, and z2 is the minimum of the values. So that's why we put as greater than 2, because we have to find the minimum.
No. When you write this greater than inequality,
Your
you
voice
can
is
compare what
not
can be
audible,
the
sir.
values. So whenever you put minimum, something minimum is greater than some number. So from there you can compare easily. If you put less than equality or less than equal to, from there you cannot conclude anything. That's why we used to do 1 minus p of that thing.
So for if we have to find f z2 that is less minimum of, and we have to find less than equal to 2, then why didn't
Yes.
we started with less than sign only?
Because let's say
in the initial
yeah, we started with this only, but you can't make a conclusion in the next step. Okay, let's say x1 is taking value 0, all values are 0, okay, and they are taking values in the combination of 0 1, okay,
Yeah.
and then they are taking values in the combination of 0 1 2. So after that, commenting on, after that, making conclusion about that inequality is very difficult to interpret. That's why we do this greater than. Whenever you have minimum inequality and greater than, now you can say, if see, you have some set of number, I'm saying that minimum of that number, okay, that minimum of that number is greater than that particular number. That means each number will be greater than that number, right? But whenever I'm saying minimum of some number is less than equal to some number, you cannot make exact conclusion, right? That's why we do 1 minus that thing. Just pick some random numbers, try to make the conclusion. Okay, you'll understand why we did 1 minus this thing. Pick some random possible values for x1, x2 till xn. Okay. Try to play with some set of numbers here. You can see why we have taken this greater than equal to. Why we are negating and then we are making conclusions.
So it was another question I had was activity 3.10, question number 3.
Okay, just hold on. Can you repeat activity?
So activity 3.10.
Hello. 3.10 question number. Question number.
Yes, sir.
Hello. Can you repeat the question number?
Sorry, sir.
Can you repeat the question number? 3.10, which question?
3.10, question number 3.
Okay, question number 3. And what is your doubt? This is on the same line, whatever we discussed with before you, whatever we were discussing, this is
So
on
my
the same
question,
lines.
so my question was, why B option wrong, sir, if it taken Z equal to 3 value?
Okay, so x is taking value 1 to 6, right?
Yeah.
Okay, let's take x is equal to 6, because you can take the summation is from x belongs to tx. The moment you take the x value as 6, now your x is taking
And in the
negative 1.
last option, sir, why didn't we do from 1 to 12 as the summation?
1 to 12.
Because Z is taking the values from 1 to 12.
But see, in one type you are conditioning here and
Your voice is
you
not
are
audible, sir.
in one way you are conditioning here and you are running over the values of x, and x is taking value only 1 to 6. This is the another representation of f of z is equal to z.
So we are finding the value of Z over the limit of x, over the summation of x.
See, I'm saying that whenever you have been asked, you have to find f of z taking value small z. This is the another representation through which you can find out, because z is defined as the x plus y. So you can run over the value of x, that is 1 to 6, and you, when you do the conditioning, you will get this part. It's the another representation. It's not like the unique representation you are finding f of z, right?
Okay, sir.
Yeah. Someone asking practice assignment question, right?
No, sir. Now I got it.
Okay, Mr. Thank you. I think that
Yes, sir.
question,
Thank you, sir.
that question relates with the base theorem or conditioning part, something, right?
Yes, sir.
Okay, so in that you have to just look at the expression. And one more thing, one important result that I have used there, you have to see when you condition on you, when you reduce the space, okay, the sum of the probability you need to check there. See, let's say you are conditioning on some particular point.
Actually, sir, I thought the in solve part and the yeah, answer part is very long, because when p of x equals to 1 condition and y equals to 10, the formula will be p of x equals to 1 intersection y equals to 10 divided by p of y equals to 10.
Okay.
And for upper part, intersection part, that will be 50c 10 1 by 6 whole to the power 10 into 5 by 6 whole to the power 40.
Okay.
And for lower part, p of y equals to 10, then when y equals to 10, then x equals to 0 and x equals to 1.
Okay.
So if just sum two parts, then we got the answer 82 by 167.
Okay.
We don't have to calculate
Exactly.
so much.
Exactly. You are splitting that into, you are using in the denominator notion of total probability, right?
Yes, sir. Right.
Okay. I think you can try that also. Yeah. Yeah.
Thank you, sir. Thank you so much.
Any other questions? Hello. Guys, if you have any question, please do ask, because in between session we have so many technical glitch. If you have any question, please do ask. Nikita, I'm audible, right?
Yes, you're audible. I think nobody has any doubt.
Ma'am,
Please
Yes. Somebody asked.
Yeah,
You can
I
go.
said like yeah. What I asked earlier, like earlier, his Ankit's voice was not clear. So I wanted to ask, like, can I like the thing which I told, like I did calculated the PMF using Pythons, and like I plotted it and I saw that it was showing a polynomial trend. So I used polynomial regression and to degree 20, and then further I used y test to divided the data set in y train and y test, and y test for the y test I calculated y predict, and then I plotted a graph between y test and y predict. It was most of the thing was in a straight line, means y is equal to x line. So like, will it be valid?
So Aditya, like you asked this before also. What you are doing,
The voice
we
was
can
not
say that
clear
you are
actually
doing
that time. At that time, that's why I didn't. Your voice was not
hello.
getting clear. Your voice was breaking down at that time.
Now
Yeah, now it's
okay,
clear.
now I'm clear, right? Like my
Yeah.
okay. So whatever doing, it's a kind of interpolation, something like that. You have some data point and you are building some, like making some function that will predict the outcome, right?
Yeah.
You're trying to fit
Polynomial
model, right?
regression. Yeah.
Polynomial regression. You're say you are doing interpolation or extrapolation and you are finding one polynomial that will fit your data, right?
Yeah.
But like, are you sure, like whatever whatever data fit you have done, that will fit your model?
Yeah,
See,
actually,
it will closely predict, right? The most accurate you can do. Yeah.
actually
Hello.
I tried for the white train, okay, and white test was hidden for the training, okay, matlab, and so I checked on the white
No,
test,
no,
okay.
yeah.
Pardon me.
So I totally got your point, whatever you are saying. But my point is, see, whenever you try to fit some model to some data, it will approximate, right?
Yeah.
So the degree of accuracy will depend on how accurate is your model or which model you have chosen. So
Okay.
for that, we need to look into the data. If you are saying it is closely, mimicking all the values, then I think it will work. But for that, we need to look at the data. We need to look at your model, and then we can say for sure, okay, this will work. So
Okay,
all
actually,
these things you need to
it
take
was
care of.
y test and y predict. I plotted y is equal to x line and y test and y predict. Some points, some points were going up. Some points were going up 2 to 3 points. Rest of the points were on y is equal to x line. Okay.
Yeah.
What the graph was? Final graph what was coming?
So whatever you must
Pardon me?
have chosen some particular data points. You
Yeah,
must
yeah.
have chosen some particular
Yeah,
data
yeah.
points
I
for.
compare. No, I actually it was randomly divided from on Y test and Y train. Okay, and on test,
Mhm.
I calculated for from X test using the model. I calculated Y predict. X test was not known for the model, and I calculated Y predict. And for Y predict and Y test, I plotted the line, and that line was coming a straight line passing through origin at 45 degree. That is y is equal to x line. Okay, so most of the points were lying on the y is equal to x line,
Okay.
but 1 or 2 to 3 points were lying outside of it. Okay, that was what I was saying.
Okay, but whatever point you looking for, if I think that is on the line or your model is predicting correct on that point, I think
Most of
that
the
will work.
points were on the line. That means that y predict and y test were the same. That what were actually is and what I predicted, model predicted was the same.
Okay, but that is like what that your data set is depending on like how small is the data set, on how many point you cross check. This you
About
also need to take care, right?
it was about yeah, thousand plus points that total. I divided into 80 and 20 ratio. 80% training and 20% testing.
Okay, and how large was the 80 or 20%, or like how
80
large was your
twenty
data set?
percent about the data had about I believe that 1000 columns, and the accordingly that thing will be divided.
Okay, yeah, like whatever you're saying, it might work. Like, but then again, for being sure, like we have to look.
If the graph is
But
coming
whatever
correct.
point you're saying, it is.
Okay, I got it. Got your point. Thank you.
Hello, sir. Hello.
Hello, Mr.
Yes, sir. Sir, I have one more doubt in lecture video 3.4. Andrew sir explain an example IPL power play over. That I can't got it. Lecture 3.4.
Okay, 3.4.
Example IPL
Okay, can you
power play
guide me in
over.
the slides? No,
Sir, last
I
slide.
got your point.
Exactly last example it was.
Okay, wait. Lecture 3.0. Give me the duration. Examples on joint margin and conditional property. You're talking about this video, right?
Yes, sir.
Hello.
Yes, sir. Hello.
So are you there?
Yes, sir.
Can you
Conditional
give me the
probability.
duration? Okay, the timing.
Sir, it's not
3.4,
open
right?
in from. Yes, sir. 3.4. Sir, you can go on.
Okay, and wait.
Last part in this video.
Isn't that example IPL power play over?
Yes, yes, ma'am.
What is the doubt there?
Ma'am, I can't understand it. Why y equals to 0, 1, 2? Because y denotes now.
That was the assumptions. All that were assumptions. So
Okay.
taking the value 0, 1, 2 with some probability, then x given y equals to 0 is uniform. All that were assumptions, and after that, so I was calculating the probability.
Okay, ma'am.
Yes. So just take that into consideration and then try to calculate the probabilities.
Okay. Because ma'am, I'm not sure cricket, so I can't understand this
All
IPL
that
example.
he had already taken few points, like these are the assumptions, and then he calculated f of x y dt dash.
Okay, ma'am. I will check it. And ma'am, in week 2 extra activity, this graph is necessary and it is optional.
No, not necessary.
Okay, ma'am. It is optional, right?
Yeah.
Okay. Thank you, ma'am.
Yes.
Yes. Okay.
Okay. Any other doubt you have? If you have, then we'll take. Otherwise, we'll wind up the session. So let me Puneet, Srinivasan, you guys have a wind up the session.
No, all good, sir. Thank you. Good night.
Okay, Puneet. Thank you. Okay, then we'll wind up today's session. Thank you, everyone. Okay.
Thank you,
Thank you,
sir.
Nikita. Okay.
Thank you, ma'am.
Thank you all.
Okay. Thank you all. Good night. Thank you.